Hello, my name is Marcos Katz. I am a professor of wireless communications at the Center for Wireless Communications at the University of Oulu. The subject of my presentation is towards truly sustainable wireless communication systems. So first we start with the relationship between wireless communication systems and sustainability. We can see this relation from two perspectives. First, wireless communication systems for sustainability, meaning how our communication systems can support economic, social, and environmental sustainability. And this is, of course, very much related to the UN's sustainability development goals. On the other hand, wireless communication systems have to be sustainable by themselves, and this is mainly the main subject of my presentation today. On one hand, the wireless communication systems can be seen as a part of the solution towards sustainability. On the other hand, if we don't make our communication system sustainable, they will be part of the problem. So we have to work towards sustainable wireless communication systems. And so what do we mean in general when we talk about sustainable wireless communications or sustainability when referring to wireless communication systems? Typically, we have been referring to energy efficiency, low power systems, energy harvesting, spectral efficiency. These are extremely important part of the sustainability equation, but we have been doing this in the past as well. 15 years ago, we have been talking about green communication. Today, we talk about sustainable communications, but in our view, we need to go far beyond these energy efficiency and energy issues to see sustainability from a wider perspective. So in this picture, we can see the life cycles or lifetime of a wireless communication system, whatever system we can consider here. And we start from conceiving this wireless communication system based on technical and functional requirements all the way in the timeline to the disposal. So the key stages of this are the design, the implementation, the operation, and then at the end, the disposal of the wireless communication system. We need to see now sustainability from a holistic approach, considering sustainability at the design phase, sustainability at the implementation phase, at the use phase, and at the disposal. I will briefly touch these four parts and sustainability by design. First, I have here some examples, and these are by no means exhaustive examples. There are some energy efficient communications that we have been dealing as communications engineers a long time with different aspects at link level, like modulation schemes, resource allocation, passive communication, wireless energy transfer, etc. At the network level, like MAC protocols, resource allocation, routing, wake-up techniques, also again wireless energy transfer and others. Spectral efficient communications, also at the link level, at the network level. I will not go into details of everything. Also, I mentioned here optical wireless communications as a way of being spectral efficient by using other techniques than radio-based, which will save us of the use of spectrum. Architecture is also related to the design, and the design, how can we devise architectures which are sustainable. And in the case of multiple networks, how can we have a network selection based on sustainability? Now we go to the second aspect, sustainability in the implementation phase. Of course, first of all, we need to consider environmental friendly technologies, supporting the use of common components, supporting the use of technologies which are sustainable, like printed electronics, biodegradable electronics, supporting the use of abundant materials and elements on the Earth, the use of ecological and durable parts, the use of recyclable parts, and on the other hand, avoiding the use of elements that come from conflict areas. This is mostly from the component point of view or parts, but also we need to take into account that the manufacturing techniques are sustainable, meaning that they use energy and other resources more efficiently. They produce less pollution, less emission, less waste. Sustainability at the usage stage, of course. First of all, renewable energy sources should be preferred, but also energy autonomy and creating solutions which are batteryless. They don't need energy, they harvest energy. So this is also related to the sustainable design. Also having solutions which are energy efficient and low power. So again, related to the sustainable design and implementation. Also, while using the communication system, we need to maintain it, and of course maintenance-free operation will be preferred, also remote maintenance. Also, we may need to modify the system or reconfigure because there could be need for that. There could be some small changes in the standardization, and we don't need to get new equipment, but if we can modify, reconfigure the system, this will be a sustainable use of the communication system. Finally, at the end of the life of the devices, we need to dispose, and this should be done in an ecological way. We may eventually repurpose the system to be used somewhere else by using the same equipment, and sustainable recycling as well. In general, I think we should create methodologies for developing sustainable communication systems, and our view is that we should see this in a holistic approach, considering, as I said, these 4 points: sustainable by design, sustainable by implementation, sustainable by usage, and sustainable disposal. Also, we should work on developing methodologies for the assessment of sustainability, how sustainable is a given system, and how we compare that system with another one. So in order to do that, we need to develop some metrics for sustainability. And finally, the relationship about sustainability and standards, and how can standards enforce sustainability. These are important issues. Next, I would like to show you how we are in practice taking these ideas that I previously discussed about holistic approaches to sustainability in a real case, a project in which we are involved. It is called SUPERIOT. We are from University of Oulu coordinating these projects, and it is the project is focused on truly sustainable systems, particularly Internet of Things. Let me share with you some ideas about the project. This first page is showing this SUPERIOT project in a nutshell. The project name comes from the words truly sustainable printed electronic based IoT combining optical, radio and wireless technologies. It is SNS project. We just started at the beginning of this year. It is a 3-year EU project where we have 11 partners and 1 associated partner. The list of the consortium can be seen on your right hand side. And so in here we are, as I said, putting into practice this idea of holistic sustainability, particularly that this SUPERIOT is based on the idea of having a sustainable design and sustainable implementation of the system. And in here we exploit for IoT for the concept not only radio technologies but also light technologies. So we provide connectivity based on light and connectivity based on radio. We provide also energy autonomy, so the nodes are batteryless and they harvest energy also from radio and from light. And on top of this, we also exploit light and radio to provide a reliable and accurate positioning. So at the end of the project, we will build several demonstrators, and soon I will show you a little bit more information about the demonstrators. But let's discuss a little bit more about the concept. So here you can see the SUPERIOT concept from the node or device, IoT device point of view on your left-hand side. On your right-hand side, the idea at the network level. So from the network side, as I said, we will use printed electronics technology to implement the node. Printed electronics will be used as much as possible, and the nodes will be reconfigurable. We can transmit or receive information using light, using radio, or eventually both of those if needed. And also the same lighting infrastructure that we have in the room, for instance, will be used to provide light by which we will power up the node based on energy harvesting from light, but also radio frequency will be used to harvest energy. On the network side, of course, we will have also IoT gateway will be reconfigurable. It will be based on the use of optical and radio signals. Robust positioning, as I said, and also since the nodes are energy autonomous, dependent only on the energy that they harvest, we will have a network level smart energy management for the system. So this is shortly. The objectives of the project, first of all, we want to demonstrate like this dual mode radio light connectivity is not only feasible for IoT, but also it will result in highly flexible and highly adaptable solution. We will like to demonstrate dual mode energy harvesting. We would like to demonstrate dual mode positioning. And very important as a part of this sustainable solution, we would like to maximize the use of printed electronics. And in the consortium, we have a few partners who are able to build, to design, to manufacture printed components which will be used in our solution. So we also want to develop, demonstrate, and advocate this concept of truly sustainable wireless communication system. In this case, considering only IoT, but we believe that these ideas could be extended to, in principle, any communication system. At the end of the project, we will build 4 demonstrators, and you can see on your right-hand side those. The first one will be a small IoT node which is reconfigurable, and it will be built using hybrid technology, meaning part of the IoT node will be using printed electronics and part will be using conventional silicon-based electronics. And all the capabilities, like I mentioned, about energy harvesting, dual mode communication, positioning, will be integrated in this demonstrator. The second demonstrator deals with a network now of the nodes that previously I mentioned in demonstrator 1. It will be used in an advanced application in medical ICT. We would like with this to demonstrate how potentially this idea could be used in the hospital of the future, where we can also manage people like a patient, healthcare personnel, hospital equipment, even objects, and we can communicate with them, we can know where they are, do things like that. The third demonstrator will be also small IoT node, which will be very much limited in capabilities, but it will be fully printed. So this is going to be also quite challenging for the project, but this will be something to show really that we can have a fully printed node. And the fourth demonstration will be a large area IoT node, departing from the idea of having small nodes. In the future, we could also have nodes which are integrated on any surface, like the wall, and where we have large area, we can harvest quite a lot of energy, so energy in that case won't be an issue. So we will study both IoT nodes or repeaters or RIS as a part of this demonstrator. Finally, the project has some visions. We think that in the future we will be able to have fully printed, reconfigurable optical radio IoT node with full capabilities, as I explained in the project. And when produced massively, they could be extremely inexpensive. We dream that in the future we could have 1-cent nodes, meaning that we could have like a sticker-like printed IoT nodes that we can use everywhere. With the advancement of printed electronics, we will be able also to produce IoT nodes which are biodegradable. So this will give rise to really novel way of using this, considering that these devices are sustainable and they are low price. So particularly we are interested in what we call massive sensing and massive actuation, in which we could put basically those IoT devices or nodes everywhere in large scale monitoring the state of a forest, smart cities, and you can see on your right-hand side some examples of where we could use. This concludes my presentation. Thank you very much. If you have any question, please contact me at the email shown on this slide. Thank you.